Okay, this is Mr. Tong, and I'm making this video for the people that need to make up the energy pyramid test. We went over the answers in class. I didn't give out the answers because this is as close to a real test as we can make it. But if students answered in the class, I confirmed it. So if you didn't get a good grade, you either weren't paying attention or you didn't come to class. So this is for you. I hope it will help you as much. It's a big part of your grade. It's a big part of your grade. Okay, so it's 12 questions, but there were 3 test points each, so 36 test points. Okay, so we'll take a look. So what you should do is open up Energy Pyramid in your assignments. And if you don't have that open yet, pause this video and then go ahead and open that, okay? I'll give you a second. Meanwhile, I'm going to switch over to this so that we can watch the energy pyramid part, okay? And, all right. All right, so hopefully you have the questions in front of you. And remember, the first question is what class you're in, and you'll need that for your makeup. And if you put the wrong class in, your name is not where it says whatever period or whatever group it is, then I am not going to look for it. I'm not going to look you up. You put the wrong one in, no credit, no makeup, okay? So you got to do that. All right, so sorry, I don't know what happened to my thing. Okay, so hopefully you can see this. We're doing it right. And I will play this.
When we were little, we loved nature shows. One reason was because we didn't have cable, and it was one of the few things we actually got a TV signal for that didn't require you to dance around with a TV antenna for reception. But the other reason was that, of course, it was cool science. It often showed animals that we couldn't see in our own backyard doing some awesome things. But then it would be a little traumatizing when, inevitably, some predator would walk in and gobble the unsuspecting animal up. Truly, action scenes with predators and prey are often shown in nature shows because it's all part of nature's food chains. A food chain starts with a producer. A producer is an organism that is an autotroph, which means that it makes its own food.
Okay, so that is question number 2. What is an autotroph? An autotroph is a producer. It says so right on the screen, right there. And so do producers make their own food, or do they have to eat to live? Okay, so take a look at that. The answer is right there, number 2. Now, number 3, and again, you can pause this video. Number 3 will be heterotrophs, consumers, and they'll talk about that in just a moment.
A plant, for example. The plant is eaten by a primary consumer, this grasshopper here. Consumers are heterotrophs, which means that they need to feed on other organisms. The primary consumer...
Okay, so that's the answer to number 3. And in class, when people said the answer, I told them if they were right or wrong, but you won't have that here. So anyways, heterotrophs, consumers. So according to what you're seeing right there on the screen, do they make their own food, or do they have to eat to live? Okay, so number 4, where is the producer level in the pyramid? So you'll see a pyramid in just a moment.
Consumer is eaten by a secondary consumer, this frog. The secondary consumer is eaten by a tertiary consumer, this snake, and the food chain can keep going. Notice how the arrows are supposed to point in the direction of the one doing the eating, which makes sense because that's the direction of the energy flow. You can also arrange the same food chain into an energy pyramid. The producers are at the base here in trophic level 1.
Okay, so she just said it. So number 4, where is the producer level in the pyramid? You're seeing it right there. Is it in the bottom, or is it in the top, or in the middle? Okay, so take a look at that and answer that question. Now, the next few questions, you have to really look at the language, the English. So I told you before, all tests are English tests. Even if they test you on science, math, history, anything else, they're really all about whether you can read it and understand what the real question is. That's why we do reading so much. It's the basis of every test we take, as well as most of the work that you're ever going to get paid for. Okay, so number 5 is how much energy is lost from producer to trophic level 2. How much energy is lost from producer to trophic level 2? And I think on your test, well, actually, if you're doing the makeup, it'll say trophic level 2. So how much energy is lost? How much do you lose? How much is gone? 10, 50, or 90%?
They actually contain the most energy. What is crazy to think about is the primary consumers here in trophic level 2, they actually only store 10% of the energy from the producers. Meaning, let's say the plants here had 10,000 kilocalories. That's an energy unit of energy. Well, the next level here, the primary consumers in trophic level 2, they would only store 1,000 kilocalories of energy. So where did the rest of the energy go? Much of it is lost in heat or undigested. If you go up to the secondary consumers in trophic level 3, that would be only 100 kilocalories of energy. So as you go up each trophic level, it's roughly only 10% of the energy from the trophic level below that will be stored.
Okay, so I'm going to stop it there. So you have to really listen to the English or understand the English. So number 5, how much energy is lost? And let me back this up a little bit. And you can see how much energy gets to the next level is only 10%. So that's like having $100 that the government gives the school. And in some really bad school districts, Antioch's not one of them, but in some really bad school districts, you might only get 10% of the money that get to the students. So if the government gives $10,000, then only 1,000 got to the student if it's 10%. That's how much is stored as you go up each level. Then how much you lose is if you go from 10,000 and you only get 1,000, then you lose 90%. So take a look at all those questions. Number 5, how much energy is lost from producer to trophic level 2? Is it 10%, 50%, or 90%? Okay. And then again, if you had paid attention in class, and you could try to go back on the chat, but there's no, you might be able to figure it out from chronologically in order, but there's no numbers. People didn't put numbers. Okay. So number 6, how much energy is lost from each level to the level above it? Okay. Which is basically the same question. 5 and 6 are the same question. You should have the same answer. If you have a correct answer, it should be the same correct answer. Then number 7 is asking the question the other way around. How much energy is stored? How much got saved from one level to the next? Was it 10%? Was it 50%? And was it 90%? Okay. Now, the next one, she doesn't say here. We say it in number 8. We say it in the PowerPoint, but I'm going to tell it to you now without actually telling it to you, but you'll be able to figure it out, hopefully. And so the energy from each level in the pyramid, you lose 90% and you store only 10%. However, from the sun to making the plants store half the energy. They're the most efficient of all of them. So they store half the energy, um, and half the energy is lost. So look at question number 8. How much energy is lost from the sun to the producer level, to the plant level? Is it 10%, 50%, or 90%? So I told you we lose half. So you'll have to figure that out. Number 9, how much energy is stored from the sun to the producer level? So we store half, and we lose half. So is half 10%, 50%, or 90%? Okay. And then the next question will be biodiversity can contribute to the sustainability of and there's a blank. And just a hint on testing, if it's an, that means that word has to start with a vowel, A, E, I, O, or U.
10% of the energy from the trophic level below that will be stored. Back to our food chain. Notice that, like a domino effect, if something is removed, let's say the grasshoppers, you can harm the others because they might not have enough to eat. You really have to consider the relationships among organisms in a food chain. In fact, even if you took out the apex predator in this particular food chain, which is the snake, you could end up with an excessive population of frogs, and so many frogs that it's possible they wouldn't have enough grasshoppers to even support them. You know, this is actually not a very good model because in real life, this snake probably doesn't just eat frogs. It probably eats rabbits and birds too, because an ecosystem doesn't typically have a single food chain. Instead, it has more of a food web. A food web is made up of multiple food chains that interact together. So notice how now we have multiple food chains here tied in with our original to make a food web. The beauty of a food web is that it shows more interactions among a variety of producers and various level consumers. It also can show biodiversity. Biodiversity is the variety of organisms, all types of organisms, living in a given area. The size of the area that we're talking about, as well as the climate of the area, directly affect the biodiversity that is present. Biodiversity can contribute to the sustainability of an ecosystem. What I mean by that is, let's say there was a decrease in the amount of small birds in this food web. Well, it's likely that will be harmful to other organisms. However, it is not the only thing that the snakes feed on. They have other options because of the biodiversity. The snakes also eat rabbits and they eat frogs. So because of this biodiversity, the ecosystem might be more resilient to changes such as these and possibly recover. However,
okay, so she is mentioning it, but it's written right there for you. Biodiversity can contribute to the sustainability of a blank, and that's one of your choices, number 10. And the next question, 11, which has more biodiversity?
These changes can still have detrimental
food chain or food web
effects, and it's why it's critical to protect ecosystem biodiversity. High biodiversity has a lot of other benefits. They can include economics, and we'll need another video to really touch on all the benefits of high biodiversity. So if we were to ask you which of our examples here had more biodiversity, our food chain here or our food web, you would definitely want to pick the food web.
Okay, so there's your answer to number 11. Okay, which one has more biodiversity, food chain or food web? And so, like I said in class, we have a great human example of it over about 150 years ago in Ireland. They grow crops there. It's a giant island, it's like big as Texas, near England, and it's where Irish people come from. And during that time, they grew all these crops, but after a while, they were growing these potatoes, and it's the same potato. Like if you put your two fists together, it's about as big as that. And it's the same one we use for baked potatoes, brown on the outside, light brown, but the meat, the potato part is nice and white. So people make, generally speaking, you can do all kinds of things with them, but generally speaking, that's the potato that they make French fries from, that they make baked potatoes from, that they make mashed potatoes from. And so you get a lot of potato for growing that plant. The plant grows on top and the potato grows underground. It's part of the root system. And so everybody started liking that potato because you got more food, basically. So they started growing that potato all over the entire island. Well, potatoes are like people, are like animals. Viruses can get to them too. So just like the pandemic is affecting humans, so there was a potato blight. They call it a blight. It's a virus, and it would kill the potato, and you couldn't eat it. And so usually a virus in a plant will only affect one species of potato, but and so if you had several different kinds of potatoes you were growing, you're probably pretty safe. It would kill one species, but it wouldn't kill the others. But because everybody started growing that potato and they relied on it for food, then that became, once the virus got in, it ran through the whole island. And people, first the potatoes died, then the people died because they died of starvation. So they did not have enough food to go around because of this virus that was killing that one particular kind of potato. So that was like a food chain, and then something got taken off the food chain, and then all of a sudden everything along the food chain dies. But when you have a food web, so like nowadays we have more of a food web in the world. We actually, even if a certain crop gives you more for the work and you make more money of it, out of it, we still grow the other kinds somewhere, so we don't ever get in the situation like that happened in Ireland, the situation that happened in Ireland. So we still have sources and we hopefully still have food. But, you know, enough things happen, we could really disrupt the food chain. I understand China is really having a hard time feeding its own people too. Most of the food in the world comes from the United States, and a third of that food comes from California. You may not know that. The world is very dependent on California Valley, the California Valley. Okay, so let me play the rest of this and then we'll answer questions 12 and 13.
One last thing. There are some organisms that we left out of our food webs and food chains, but they're kind of a big deal. Decomposers. Decomposers are heterotrophs since they do eat other things, even if the things they're eating aren't dead. Decomposers include organisms like bacteria and fungus. Technically, if we were to draw them in, then every arrow here would eventually point to them. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.
Okay, I'm going to close this and then show you the PowerPoint. And okay, so let's hope that works. Whoops, I don't think that's working. And I won't go over. Well, actually, I better go over it. So I'm assuming that you did not pay attention the first time or you were absent. So I don't want you to miss what's an important part of your education. Okay, so here we are on this particular PowerPoint. So this first part is review. The energy pyramid is made of several trophic levels. So trophic level is just a feeding level. So it's like if you ever feed animals or you have grandparents or relatives that do, the big feeding container, some places use containers. So it's a trough. It's like you watch the old Westerns. There's this big horse watering trough where the horses could drink water, and they always like knock the bad guy or the good guy into it, and they're in all that water. But that's a trough. That's a feeding trough. So a trophic level is just a feeding level. And so the primary level we talked about So it's more, I know it's hard to see this, but it's more of a pyramid like this, not really like Egyptian pyramid, like a triangle. It's more really big on the bottom, remember? Because it's 10 to 1. It's like you lose 90%, and then you only have 10% of energy that goes to the next level, the level above it. So you have the primary producers, which are always autotrophs, always plants, and then the primary consumers usually are herbivores, animals that only eat plants or insects that only eat plants. And then the secondary and tertiary is like a fancy word for third level. And then there's another level, quaternary. And most ecosystems can barely do 3, let alone 4 levels. But the second and third usually are carnivores and omnivores. So like humans are omnivores. And so that means we eat, sometimes we're primary consumers, we eat the plant, or sometimes we're secondary consumers, we eat the animals that eat the plants. And for people, for humans in our culture, that's pretty much what we do. We eat cows who eat plants. We eat chickens who basically eat plants. We eat turkey, eats plants, and we also eat pigs, which are omnivores. They eat plants and animals, and so we rarely. But then there's fish too. There's some fish that only eat plants, but then there's some fish that eat plants and animals. So, and just to make this point, you are an omnivore if you're a human. So even though you might not eat a lot of plants or vegetables or salads or anything like that, you still can digest them for the most part. And so you can eat plants even if you mostly are a meat eater. And if you're only eat plants and you say you're vegetarian and you don't eat meat, that's by your choice, but you can digest meat, even though you say it makes you feel sick. I've heard vegans say that, but you actually can if you had to eat it to live. Okay, so anyways, that's where we are. And so let me go to the next slide. And so energy is lost, which is really kind of like the whole point, major theme that goes through all your different grades in science. Where does the energy go? So basically you're losing half the energy from the sun to the plant. And then after that, every level you go up, every feeding level, every trophic level you go up, you lose about 90%. And then you only get 10% that's stored. So let me give you an example. Here's a picture of the haystack we had 2 years ago, just to show you how tall it is from here. Here's an extension ladder. So it's about, 15, 20 feet tall. And so these are the same height. They just don't look as tall. It's just the way, the angle of the picture. But I had to put these away this year for our 5 horses. And so here you can see it's about 196 bales. They're like 96 each. So 2 bales is like 192. Plus I had to get a couple more bales for the mini horse and stuff. And actually it was way more, but let's just use this number. And so they weighed about 125 pounds, pretty dry to put away. There's some years that we got bales that were like 200 pounds, 150 pounds, because they were still a little wet. I mean, they're not sopping wet. They're not wet to the touch, but they're not super dry, right? And so then they were really hard to put away. But anyways, let's just say this year, 196 bales, about 125 pounds each. Okay, so that's 24,500 pounds of hay. Okay, so question number, and that's to feed 5 horses. So here we are on the basic primary trophic level, level 1, and we have the plant material, which is the hay. So how many pounds of hay? 24,500. That's your question number 12. Okay. And so then again, I'm going too fast, just pause. All right. So if I have 5 horses, this is 3 of them. If I have 5 horses, and let's just round this number off to about 25,000s, because remember 24,000, and if you have 500, you round it up. If you have the 5, you round up. So I have 5 horses. So how many pounds of hay each year per horse am I feeding? Okay. If I have 25,000, 5 horses, how many pounds of hay am I feeding every year? That many. Okay. And that's question 13. All right. Well, hope you did good on the makeup test. If you, before you press submit, take a look and see if you have any questions about any of those answers. Hope you did good, because they are worth 3 points each. So that's 36 test points, which will take you from an A to, it depends how high your A was. But anyways, most of you guys went down, but some of you didn't. So some of you did good on the test already. But if you're taking this, you probably didn't do good. You probably got a 0. Or you, if you were absent, and you probably got low score, or you wouldn't be taking this. Okay, hopefully it all works out. So Mr. Tong, out.